Welcome back to Pencil Paper, and this is the episode 2. So we're going to start talking about the problem 1 from the last episode. So it is a problem about dissecting a rectangle 9 by 16 into several pieces and recombine them into a square. So I think we have like several methods, and each of them is pretty efficient. So I will present the first one. Okay, so in the first method, we want to like first construct a segment of length 12. So I create a segment of length 12 here, and then we want to create a right angle. So we draw the altitude here. So we have 3 pieces right now. We want to recombine them into a square. So what we do is we translate this triangle to here, and translate this triangle down here. So it's obvious that this segment is equal to this segment, and this segment is equal to this segment. So we have the square of the side is 12.
So India, what do you do?
So I did slightly differently. So when I saw the rectangle, I thought about how I can use just triangles and combine them to make a square in using the dimensions that are given. So I was doing mostly horizontal, vertical, and diagonal kinds of cuts. And then, so I was thinking, first of all, you need to make a side of length 12, like Yannick said. So I decided to start the cut here. So we have a side of length 12 and then 4. And then the same from up here. So if we draw a cut that goes from up here to this corner, now we have a triangle that's looks like this. And then I was thinking about, if you want to make this 12 actually be inside of the square, we can slide this triangle up. So now it'll look like this. And now it's pretty clear what to make the last cut. So if we make this cut here, we have a triangle that's 3 by 4 because it's similar to this one. And we just take this triangle now and then move it up here. So we can get our 12 by 12 square.
So in my point of view, both of your method is more or less you hold the square with the what? With the rectangle. For your method, you put it right over here and then see how you make the cut. For him, it's like, instead of you put the square down here, you turn it a little bit. But how much do you turn? You have to find these special angles to do that, right? So that's, both ways are basically finding the common area between the what? The rectangle and the square. Over here is this, over here is this, right? And actually, I have another cut. It's different from this, and we will present it in the next section. Okay, and that one, the reason I said we want to present in the next section is that one is not easy to do. Okay, in this way you go with the angles, you go easily. The next one we will do is somehow involving the midpoint, and that is trickier. Okay, so we talk about this too. Is there any way we can reduce the pieces?
So I think I remember a way sometimes the staircase cutting that works particularly well with like integer side length. So we have 9 and 16, and we separate that into 3 equal pieces and 16 into 4 equal pieces, and we make a cut like this. So we have 2 cut through pieces, each looks like a staircase, and then we move this up here. And we have a square. So this method only cuts into 2 pieces, but the cut is not a straight line, so we might argue that it has 1, 2, 3, 4, 5 cuts.
The other 2 methods have less cuts, but one more piece. This one has more cuts, but less pieces. right? So that's a very good way. And also, in a certain way, the second and the third method are very similar. It's about a move up, right? The third method using the ratio 9:4 better, right? The second method doesn't even need to worry about that. But the second method could be more general, because this one clearly depends on 9 and 16 and 12, that's 3 and 4, right? Yeah. So all these methods are good because they lead to different ways of solving different hardware problems. Okay, so this is just an introduction about cuts.